Hey everybody, how is it going? Haven't seen you in like 3 days. Can you believe that? Wow. All right. No, mic looks like it should be working. Uh, yes, 6 viewers. Cool, 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 cool. So we'll just do a good review. Oh, we're down to 5. We're down to 5 already. This is tragic. Um, so I figured I'd just give you a rundown. Haven't done a review in so long. My drawing tablet is currently out of batteries. It's charging up, so I'm gonna charge it for like 10 minutes and see how far that'll get me. Um, and we'll go from there. But for now, we can talk about some stuff before that happens. So first of all, I wish I was watching it. I probably will be. But I promise you guys a review, especially because I wasn't here today. If I was there to review with you guys today, I probably would be watching the national championship. I will. I got it on. I can catch up. So once we're done in like an hour, I can watch the first half fast. Okay, or most of it actually. It looks like what I'd probably be having to do, but that's okay. Um, yeah. What else? What else? What else? All right, I'm just taking a look. We're up to 9. And all right, we're at a 10. 10's all we need. Actually, again, I still I gotta charge it for a sec, so I really wanted to get started with this. But I mean, I'll just run through just verbally. And in the background here, look, I get a live alert right there on the screen. Oh, I'm blocking it, but yeah, apparently Clemson has the ball. I don't know. Anyway, uh, thank you. But the what we can do is, like I said, we'll just go through. We'll go through it, and we will. Sorry, my notifications were going to my computer, so I just got to stop that. All right. Yeah, so we'll just go through some of the basics of what we got here, and yeah, how about that? Sound good? Anyone else gonna say anything, or just Kevin? Just Kevin and I are just chatting here. Um, okay. Anyway, all right. So the idea, basically 7.1. There's a couple different types of problems that you're gonna see. And sort of how to relate to each other. But the main idea is that a ratio is just a fraction that can be written, or it's just a relating two numbers together that can be written as a fraction. It can be written with a colon between them. It can be written with the word 2 between them. Basically, it's comparing two numbers, and two ratios that equal each other is going to be a proportion. And we use proportions to solve a lot of stuff. Basically, yeah, solve similar. I mean, because sides are proportional in similar figures, we can write proportions. Then we got some of the. Okay, so that just recap that a little bit. We have extended ratios, which are more than two together. And of course, when you have these types of problems, and again, we can. I'm holding the pen like I'm going to write down stuff, but I can't. Now I just dropped it. Got it. We're good. So basically, if you're looking at something like this, I know we did this as an example, so it shouldn't be so bad. But if you had a ratio that was like 2 to 3 to, maybe I can just use my 2 to 3 to 5 to 7. Um, Essentially you're just going to make it 2x plus 3x plus 5x. This is much harder than just writing it out using a mouse here, guys, so forgive me. All right. And then, so the total of this is going to give you how many parts there are total, right? So it's the idea is, let's see, 17 is what we got. So there's 17 sort of total parts, but this represents 2 of those parts, this represents 3 of those parts, and 5 and 7. The main idea is we just have to set this equal to something. Now, if this is talking about angles in a quadrilateral, it's 360. If it's talking about sides and the perimeter is 85, then I'd put 85 there. Obviously, that's what we had to do in this case. But the idea is you got to figure out what the total is of these things, figure out how many parts there are total, and you just split them evenly, essentially. And then once they're divided, then you can go back in and just plug what you get in for x, right? If you find out x is 5, well, then we know that sort of all these values. This is 2 5s, this is 3 5s, this is 5 5s, and this is 7 5s. And that should, and you can always double check. You can always go up and add. Hi, Michael. Hi, Samantha. Sam. I don't ever call you Samantha. That was weird. Um, Okay. Let's see. Okay, so then we have the proportion. We don't really need to worry about too much about the means and the extremes yet. That's mostly the next chapter. We'll come back to those. We do need to know that, of course, the cross products property. Again, most of us have this down anyway. If you have a proportion, you cross multiply and you solve, right? So we know how to solve these. Do you think I'm going to give you one of those, or do you think it would be more like the more difficult ones, or the ones that involve squaring something? I don't know. I don't know. I don't really know which one I'd give. Um, I don't think I'm gonna tell you. I just, would I give you a super easy one for that particular one? I just don't know. So we'll move on from that. But basically, it's nice when you're writing in proportion. A lot of times, especially in similar figures, that doesn't. A lot of times, there's a lot of different ways to write the proportion. So as long as you're matching things up right, you should be all right. And again, what I mean by that is if you had like, you know, like the big side over the small side of one triangle, and you have to do the big side over the small side of the second triangle. Or if you did like small side over one over small side of the other, then you have to do, and then you have to do big or big. Can we do more like three? Yeah, I'll grab a few. I just again because like I said, I'm not sure if Ella, what do you think? Do you think did I give a hint here? I don't know. Again, that's algebra, and again, we've done a few of them. We'll do a few as far as the like. That's one of them. Yeah. Again, they're just cross multiplying, solving. And I know that, I mean, it's straightforward. There's room for error. I get that. Okay. But what we will do some. I do want to just go through all the sections while my pen or while my tablet thing charges that I use to write on. See, I don't have a fancy one, but it is charging currently. Okay, so um, I feel like I should get a green screen. That would be cool behind me, right? Can I do that? Just pretend it's not the background. Cool. All right. Let's see. So I wouldn't even know how to set that up. Okay. Okay. So I mean that's basically it. If we work through these problems, we'll come back and actually do some of them. Any ones that you have questions on, or I can make up new ones. That's fine. But the main idea here is ratios. Give me one sec. Uh, Oh, good question. So no one made me a theme song or an intro video or a theme song with an intro video. Um, I'll show you what I mean at the end, guys. It doesn't have to be long. It just has to be something simple but cool. And I'll show you a good example of a couple. I'll see if I can find some on YouTube at the end, okay? As far as the videos go, the intro videos. Okay. Sorry, I'm getting uh, texts from people. Um, So again, I didn't really have a chance to. If anyone emailed me today, I didn't really have a chance to check any of my email, simply because I was at jury duty today. I think I told you that. So I didn't even. I went in at like 7:30, waited in a line to go through the metal detector to the courthouse, waited in line to get my ticket or my parking verified or validated. There it is. So I waited in line to wait in line to then sit down to wait for an hour while getting instructions the whole time about what to do if you're a juror and like listen to the judge and all this stuff. So it's kind of a cool experience to be honest. But so I waited and then they're drawing random numbers, right? So there's probably a 300 people. I don't know. Maybe let's just say 300 people sitting down and all the seats are in the whole room, and like sort of throughout the whole room. There's a lot of open seats, but it's a huge room with a bunch of seats in it. So it's A lot of people, probably like 300, and they're calling people. They're calling people for jury duty, and I don't know how many people they're calling at a time, but they're calling for the first one, the second one, and my number is 517, if you were wondering, and which is my daughter's birthday, so I knew it, so it was good. I just had to listen for it, so I had to listen to all these numbers, waiting for me, waiting for me, waiting for me, waiting for me to be picked. Finally, I mean, it's like an hour goes by, 2 hours goes by, and they're calling numbers, they're calling people, and by the time they like sort of it was coming like 11:30, 12, and then they're like, all right, we'll have a little break, and then a bunch of the people who were called, who were waiting to get out by into the courtroom, or whatever, they left, and so there's like 22 or something people of like their original 250 to 300 people or whatever in the room, and I never got called, and so they dismissed me. So I never even made it to a courtroom, never talked to a judge, never answered questions, never did any of the cool jury stuff that I got to do. So, but I was out of there at like lunchtime. Um, so yeah, fun fact. That was my fun jury story. I'm also killing a little time for this thing to charge. So, I know that, but I figured you totally want to know why I was not at school today, right? I was totally right. That was a great story. Okay. Yeah, so Kelly Dunn made me a song, but I need some way to figure it out. Anyway, I don't know how the theme song for live streams turned into jury duty explanation, but I made it happen. So yeah, okay. Anyway, we'll move on. Okay. So again, if you did the homework and the homework made sense and you could repeat and you could do what it is, then like I'm confident in you. I mean, a recipe for salad dressing calls for oil and vinegar, 5 parts to 2 parts. You use 1/4. So like this is a relatively straightforward ratio, but the problem is that it deals with it. You know, you have fractions, and you're dealing with 5 to 2 and 1 1/4 cups. The main thing is, work the fractions like you know how to. You can convert to a decimal if you need to. You can convert it to a mixed number if you need to. And so the idea is, yeah, you could work with that. Yeah, you might have to. Okay, so I happened to see that in front of me, um, but don't be scared about mixed numbers or fractions. Okay. All right. So then 7.2 was about. I said. Oh wait, that was from Xbox. All right. Anyway, so this section 7.2 was about similar figures. What similar figures are, and then more specifically, no, I lied. That was it. It was what similar figures are. Is that right? Yeah. Similar triangles, but also similar polygons. And the main thing is that you end up with a similarity statement right here. Like you end up with like a similarity statement that tells you, just like a congruent statement, kind of everything you need to know, right? You're basically thinking that, oh, angle A is going to be corresponding to angle E, so those are going to be congruent. Um, Give me 1 second. Sorry about that. Okay. No, where did it go? Oh, there it is. Found it. Okay. All right. Sorry. 45. I could probably do 45. Which section? This one? Yeah, I mean, I'm gonna come back and do the problems, and just let me run through just the general ideas, and then I'll make it back there. But the idea is similar polygons, right, have corresponding angles are congruent, while their corresponding sides are proportional. That's why we can, if we know they're similar, we can write proportions, right? We can find two sides that have we have a value for and write a sort of a statement. We can write a fraction that'll give us the similarity ratio, and we can use that similarity ratio. So what we again, I should definitely just maybe we're okay. Anyway, 7.3 was basically saying just about triangles. There are three ways we can prove triangles similar using angle. So if we know two angles are congruent in two triangles, that's enough to say that they're similar. Side, side, side. That's if we know all the sides are proportional. So if you sort of match up small side with small side, or if you have a similarity statement, you match them up that way. But if you match them up, properly, and you end up with all those ratios simplified to the same thing, or they're cross multiplied. But if they're proportional, they have the same ratio essentially. Then you have that, and then we have side angle side, and then we have and so side angle side is two sides that are proportional with one angle included or between them, right? So if you have that, we should be able to prove there. Um, okay, and then of course the statement matters, the Miller statement. We did those. Okay, 7.4 was about the proportionality theorem. So there were three of them, and basically it was that if you have a line parallel to a third side of a triangle, it's going to cut those sides proportionally. So like AE over AF equals EB over FC. If I'm looking here, right? So it'd be like that and that would be proportional to like that and that. I know that's not what you say, but I just want to show you which ones I'm talking about. Right, so I could write a couple proportions there, but that's fine. That would all be good. The converse of that basically says that if they're proportional, then they're parallel. This involves if we have multiple parallel lines, like three or more, and then two transversals, it basically is saying that we're cutting like these pieces proportionally. So that could say a lot of things. That could be like, this part over this part should equal this whole thing over this whole thing. Or it could be like this part over this part equals that part over that part. There's a bunch of fractions and proportions we can write that actually would help us solve that. There's an example there. Then the triangle angle bisector theorem. This is the unique one. It doesn't involve parallel lines or anything, but if you spot a angle as being bisected, right? So we see that, yep, there's an angle that's being bisected in a triangle, right? This angle BAC is being bisected by this line right here. It's saying that's coming along and it's going to split this side into two parts. Those parts are proportional to their sides, to their adjacent sides of that triangle. Basically what that means is that if I spot an angle bisector, that this over that equals that over that, right? It's like the 10 over x plus 2 would equal 14 over 2x plus 1. I feel like that's the easiest way. So if I spotted this one, I'd be like, oh, angle bisector, that over that equals that, that over that. And you could just spot them. Oh, there's one more over here. I think I missed it. Okay. And then finally, we have 7.5. 7.5 kind of wrapped this up and threw some word problems at you, right? They involve proportions. We have indirect measurements, which are just, here are some word problems that have similar triangles, right? The shadow problem is always a similar triangle problem, and you're going to want to, you're basically going to want to, make sure, hey, these are going to have to be similar because these angles to the sun are the same, assuming we're talking about the same time. These right angles are the same. Boom, these are similar because of angle similarity. And because they're similar, we're allowed to sort of write a fraction, or sorry, write a proportion and solve for a missing value. Then we have a scale drawing. A scale drawing, we just use that scale that they give us as one of the proportions, as our similarity ratio, essentially, and then we can solve for anything. So if it's like, hey, on a map of 2 miles was represented by 1,100, I'm going to say, feet, I don't know why that would be a map. How about 2,000? How about 100 millimeters? I don't know. That would make more sense. Then how many millimeters, right, would be 6 miles? Well, we just write that out. 2 miles over 100 millimeters equals 6 miles over some amount of millimeters, right? That's the idea. You can cross multiply. Okay. Um, then the last thing was, and we did a couple problems like this as well. So if you remember the examples that we did, you should be good, especially like this was a good one right here. I mean, as far as examples go, there are other like it will do. And again, I see that you have some specific questions. I will be happy to go back and get those. But So, all right, we have the idea is that if we whatever the similarity ratio is, and that's just taking two sides that are the same, right? So AC matches up with DF. So AC DF. Okay, so AC is 4, DF is 8. So our similarity ratio from this one to this one is just reduce it 1/2, right? You always reduce the similarity ratio, so it's just 1/2. So whatever the similarity ratio is, which typically you can find, the perimeters ratios will be the same, right? It'll be 1 to 2. So if this perimeter, again, if you didn't even know what it was, but the perimeter was 20, but it was 1 to 2, then this would be 40. It would double it, right? Actually, it's 12 and 24, but in any case. And then the area is a little different. The area is always the similarity ratio, but then squared, right? So it's a similarity ratio squared. So if you found the similarity ratio, square it, use that as your proportion to solve for the missing area. And again, we did that in this question here, which we'll probably do an example of. All right, I'm going to check to see if this pen's charged. So give me one sec. Actually, you can watch me do it. See, look, I'm doing it right now. You don't even know. Oh, it's not super low battery. It'd be cool if it connected though. That would be cool if it connected to Bluetooth like the first time. That'd be super cool. It didn't, so we're gonna reset this bad boy. Oof. All right, we're gonna have to do some stuff to make it work. Why are we gonna have to do some stuff? That is the question. It connected 2 seconds ago. I'm just talking now. Sorry. It should have enough charge though. It doesn't say that it's low battery, which is great. Okay, there we go. All right. Look, I can write now. Cool. Okay. All right, so there we go. Not a high-tech fancy setup here. Anyway, my posture's terrible. Okay, so so let's do some of these problems that you guys actually had. Someone asked about 45. So 45, I believe that was referring to the first one, the first section, if I am not mistaken. And then just fire them off. I'd be happy to do some examples, especially from the homework and stuff. But I will also then, if not, I'll just probably start doing problems that are good, or just making up problems that would be, useful to you. Okay, so 45. This one's actually not that bad. I mean, the idea is like, hey, which one is this equivalent of? And the only thing I would do is just think, well, if I cross multiplied, which would be my next step, right? Just it would be 3 times y would equal 5 times x, right? That's what this is equal to. So all I want to do is if I have a fraction, cross multiply it and figure if that's the thing, figure out if that's the same. So in this case, it would be 3x equals 5y. Nope. This one's 3x equals 5y. Nope. If I multiply this across, this would be 3y equals 5x. So it looks like that one, and that one's not right. So the idea is I just go with that next step. The next step would, when you cross multiply, would be a 3 times y and a 3 times y and a 5 times x. So I just would cross multiply. 5x equals 3y. That's the same thing. So in that case, it's just h. Okay. Be more like 3D. So that was basically. I think this would be a good example to do. Again, it's going to be one of the more fun ones you're going to have. Oops, why is that drawing? I didn't want it to. Okay. So, I mean, we're still cross multiplying, right? That's the idea, is that no matter, I mean, we see that we have a proportion, we know we're going to cross multiply. The main thing is we're cross multiplying this whole numerator by this whole numerator. So when I rewrite this thing as 2m plus 2 times 2m plus 2, right, equals 3 times 12, which is this 36. I have to account for like these binomials being multiplied, which means I'm going to have to uh, do FOIL, right? So 2m times 2m is 4m squared. 2m times 2 is 4m. 2m times 2 is 4m, so we get 8m. And then 2 times 2 is 4, right? And then I have a quadratic, right? It's squared. So we just need to subtract this. We get negative 32 plus 8m. Everything else just comes down for the ride. Remember our rules from before. We see that I can factor out just a constant here. I can factor out 4, right? So we get 4, because 4 goes into each one of these coefficients, right? So I'd say m squared plus 2m minus 8. And then I can factor this, right? So we get 4, and then we know it's going to be m and m. Again, I'm trying to make it as easy as possible, but they always will be factorable. I mean, I know it's kind of slanted there, sorry. So we're factoring it. Again, what multiplies to 8 gets a 2, right? I mean, it's 8 and 1, or it's 4 and 2. It's got to be 4 and 2, and the bigger one has to be positive, so that's the 4 minus 2. Remember when we can say 4 equals 0, that doesn't make sense, so we're not really worried about that uh, that constant that I factored out as a value, so we know it's not going to be it, but we know that m is going to be either, if I set that equal to 0, m is going to be negative 4, or m is going to be positive 2. Um, and really the idea is they're both like okay, they're both fine. Like if I plug them back in, the idea is that they would actually, like if I plug them back in, that they're both fine. So both these solutions are perfectly valid. Again, there's no context. Like there's not like 2m plus 2 is representing the side of a triangle or an angle or something in this case, where a positive value would actually be, we would have to have a positive value or whatever. Actually, and they both end up being, well, no, but the point is that they in this case, like they don't have to be positive value because they're not representing anything. So that would be an example of one. Again, I think the things that people make mistakes on a lot of the time is that if they're, we have something like 2 x times like 6x or something, we need to make sure we're just multiplying them all, so we end up getting 12x squared. And when you get an x squared, you're either going to be square rooting something, or if you have to FOIL something, you're going to be sort of factoring, right? There's going to be some factoring involved, and stuff like that. All right. All the angles in a polygon have to be congruent to each other to begin to prove them similar. Well, in a polygon, yeah. In a triangle, there are shortcuts, right? We have those 3 shortcuts. You only need 2 angles to be proven. But in a polygon that's not a triangle, yeah, you need to know that all the angles were all but yeah, all the angles in similar figures are congruent. I think that would be what you need to know for that. Okay. So even something like this, right? You want to make sure you could deal with that. I mean, that's just 1.25. That one's not so bad, but you'll okay, I already went over that. I already mentioned that. Okay. Are there any other specific questions that you had from the homework? Can I just, let's see. Sorry, I'm trying to read through this a little bit. I'm not going silent for fun. Yep. Okay, make sure you distribute. That's a common mistake that people make. Things like if I had, where's my pen? Come back. Oh, I had it upside down. So if I had like 2x plus 3, over x plus 1 equals 3 over 4, whatever. You just want to make sure that when you're cross multiplying, it's this whole thing, so we have to make sure to distribute. So it'd be like 3 times x plus 1, make sure you distribute, okay? Again, whatever the scale happens to be, you can set it as you can make that as your proportion and just cross multiply and solve from there. We talked about if you had an extended ratio and you had a total amount of things, right? So, I mean, it could be anything. It could be like if I was, I had in my sports bag, right? The ratio of like tennis balls to golf balls to baseballs. I don't know, in this big bag that I have. I don't know. I don't have this. It's not a real problem. Would be like 5 to 2 to 1, right? Those would be the ratio. Well, all you'd have to know is like that's the ratio of what the balls are. You need to know what the total is. And all you have to do is basically say 5x plus 2x plus 1x equals whatever the total is. Solve for x and plug it back in. Not so bad. Again, I talked about one of those already, so we should be good. I mean, I can't do anything more than basically flat out tell you that there's a shadow problem. There always, I mean, there's an example that I gave that I went over very in depth in class as far as the example goes. Is a shadow, it's a shadow problem. The shadows are making similar figures. You got to draw it out, put things in the right spot. Shadows, I mean, there's some example problems like that as well, but shadows are not the vertical part, right? If I was drawing similar triangles here and I had a tree and a flagpole, these would be the shadows, the things that would be flat on the ground, right? Right? And then just those are sadly common mistakes people are making. More common than you'd hope. Let's see. Let's clear some room up here. Wish I could do that faster, but apparently I can't. Okay. Okay. And then remember that if you have two triangles and you're trying to match up which sides are which to write a proportion to write that similarity ratio, like which sides am I matching up? Just match up the smallest to the smallest, the largest to the largest, the medium side to the medium side, and the middle side, right? And if you are given, if I said the two smallest sides of two similar triangles are 8 and 12, well, you could just be like, oh, well, then the similarity ratio from that small one to the big one would be 8 over 12. I'm matching up the two small sides, right? Um, Remember, if they give you a similarity ratio, like if they said W, X, Y, Z is similar to A, B, C, D, right? If they told me that, right? And that obviously would be a polygon because there's four sides, right? But the idea is that you can match up the angles, right? You would know that angle W would have the same measure as angle A. Angle X would be congruent to angle B, Y is congruent to angle C, Z and D would be the same. You would also know that WX over AB would be the same ratio as XY over BC, right? You could match up those corresponding sides. Cool. So look to the similarity ratio there. Or look to the similarity statement to get your values for your similarity ratio. Remember, all that is just two corresponding sides, which you got to reduce it. And remember, the similarity ratio is I would have to say what's the similarity ratio from this one to this one, and that way you'd put it on top. So like I'm gonna make up a side. Let's just say WX was 5, AB was 2, right? Well, the similarity ratio from this one to this one would be 5 over 2. The similarity ratio from the right one, ABCD to WXYZ would be 2 over 5. So it does matter. Just read the question, make sure you understand what's happening there. If you're talking about proving similar triangles, right? There's a ton of them in there, but like, hey, which side? Like, do I have three sides? Are those sides proportional? If the sides match up, right? If I had three triangles, and again, we looked at this pretty in depth on the examples in class. But again, you're trying to determine if you have three sides, try to determine side, side, side. If you have two sides and an angle between them, see if these two sides are proportional and that those angles are congruent. If you just have two angles, if you have a bunch of angles and you have two angles that are the same, first find all the missing angles that you can, right? That includes like vertical angles are congruent and linear pairs and all that good stuff. But but the uh, but anyway, so if you're dealing with angles, like that's it. And remember, parallel lines make congruent angles, all that good stuff. Um, So, I mean, those are your three options for hey, are things similar basically, right? That's if I asked you if two triangles were similar, you would try to prove them similar using one of these three things. If I said why are they similar or are they similar and how do you know that? That's one of those reasons. Like these are the reasons why things are similar. Okay. Um, so yeah, solve for the missing angles, see if the angles are congruent. Um, if you have sides, do side over side equals side over other side, and see if those two sides are proportional. And then if the angles between them are congruent, side angle side. If they're not, or if the sides aren't proportional, then you don't have to worry, and you know that they're not similar. Okay. Again, there's a bunch of those that we did. Let's see here. Actually, I just went the blank there, but okay. Again, the properties, of the parallel lines, the similarity properties, angle bisector one, stuff like that. The main thing is, the things are proportional, so you can write, as long as you're consistent with it. If you're talking about, again, if I had something that was like, oh, that's terrible. Okay. But my point still is valid. Like if I had something that was like, those were parallel, I would know I could say like this over that equals that over that. Like A over B equals C over D. I know I could say A over C equals B over D. I also know that like I could do A over this whole side, A plus C equals B over this whole side. So it depends on what I'm looking for. But there's a lot of proportions that involve either, adding two of those segments together or just the segments themselves, but you can sort of um, deal with that. And again, we've already talked about the angle bisector one. The easiest thing to do is just, hey, if we spot an angle bisector, we know it's splitting it up into two parts here. We just know that that over that equals that over that. Okay. Get out of here. Another reminder, just as a serves as a reminder. Again, definitely 100% told you in class as well, but I'm putting this out there as an additional reminder, and that would be we talked about the do nows, like some of the do now type questions will be on there. And again, what did we do in the do now? What we did, we essentially graphed absolute values and we graphed square root graphs. And so we just remembered that our absolute value graph, right? So if I had like, let's say I had like, I don't know, come back here, okay, so 2, so we had f of x, right? So this function, 2 times like x minus 2 um, minus 3, right? Like I know that this graph looks like a V, right? So like that's the base graph to absolute value is just this. That's terrible, but it's centered at the origin, and where that bottom part, that sort of point, that vertex is shifted is based on this, right? Whatever's inside, we do the opposite of it. So this would be moving to the, because it's opposite of it is positive. This is moving to the right 2 and down 3, right? So like that tells me down 3, that tells me right 2. So I'd be moving 1, 2, and then down 1, 2, 3, right? And so I know that it would be there. And then what I would do is I get the x and y intercept. Again, to get the x intercept, the x int means y equals 0. So we did, I think, one every day of this, so we did 5 of them. The main thing is those the two graphs that we had were absolute value, and we had, if you end up with a square root graph, so if I had almost the same, if I just had like y equals radical or radical x, it would just be a graph that sort of is kind of like that, right? Where it's only sort of one-sided here. It does still have sort of, it starts at like the origin there as well. And so it's modified in the same way as this. So again, if this was x like plus 2 minus 3 or something, well, I would need to move it to the left 2 and down 3. So I would basically be drawing that graph. I'd find the x and the y-intercept, use those as points, and I could sort of sketch it out, right? Again, I don't know how much more clear we can be. You're going to have one from like the do now. It's either going to be your radical graph, right? Your base graph like that, or an absolute value graph. Right? Oh, the other thing about it is remember that if the coefficient out front is negative, right? So like y equals negative radical x, that would basically just be almost the mirror image of this, right? So instead of it being starting at the origin and going up this way, it just goes down that way. That's exactly what it is. It's the mirror image. Same thing with this. What's the mirror image of this one? Well, it would be, oh, that's what it would be. Sorry. The mirror image would be down here, right? So if it's a negative value, it would be that bottom one. Sorry. Okay, so we definitely, again, talked about that enough. I haven't been looking at the comments, so maybe if you guys were asking questions, I didn't look. All right. I'm just glancing at some stuff. Okay. Okay, yeah, we talked about similar figures. Again, I don't know how much more we can be. Perimeters, again, if you did the homework, there are definitely some, I mean, we did some of these in here, right? We talked about the area ones and stuff like that. Again, I'm going to check the comments now, make sure you guys, if you have any specific questions, sorry. Like I said, I totally wasn't looking at that. 7,433, thank you. 7,1, okay, so that's way down here. Let's zoom out there. 7,4. Number 33. Okay, so again, if I didn't have a diagram in this one, this would be one that if I looked at your homework and there was no diagram here, it'd almost be like, huh, I wonder how you would have done that besides just randomly guessing a multiple choice question. But if you actually drew it out, then I don't think it's that bad because it basically says, hey, we have a triangle ABC, and of course, if your pen runs out of ink, that's what it would look like. So I have triangle A, B, C, right? And it says the bisector of A. So this is splitting angle A divides B. Okay, so it's splitting angle A. It's a bisector of A. So it's splitting BC into segments with lengths of 16 and 20. So it says AC, this is 25. This is 16. Splitting BC into so 16 and 20. And AC is 25. Which of these could be the length of AB? And the only tricky part about this one is that I didn't know which segment was which. Right? So the idea is like, well, what could this be? Well, we'd almost have to try two different things, right? We'd have to say, well, 25 over 16 is going to be equal like 20, 25 over 16 equals x over 20, right? And we would solve. But also remember that this could be 20 and this could be 16, so it could also be 25 over 20 equals x over 16. So we just had two options in that case. I think that's why that was tricky. I guess it would probably have to be I think it would be this. Wait, no, maybe this. Here, I think it's J. I think. Again, without doing that, I'm pretty sure that if I cross multiplied that, it would work out to be that. Okay. All right. Good question. 7-5, 18 through 19. 7-5. Wait, pass it. Oh, these. Okay, these are good ones. Okay, so it gives me a pentagon and actually gives me two pentagons and it's telling me they're similar, right? So here's my similarity statement here. It's long because of the word pentagon in there, but it's the same thing, right? These vertices match up, right? So I know angle A is congruent to angle F, angle B is congruent to angle H. So if they said, hey, the measure of angle C is 88 degrees, what's the measure of angle H? You'd be like, it's 88 degrees, okay? But that's not what it's asking in this case, but that could be an example. So the idea here is that, okay, the only thing I know is AE and FK for these, right? That's only the particular size, but AE matches up with FK, right? They are corresponding. So that alone would tell me that that this right here, the ratio of from this one to this one, well, that's 90 over 60, right? So I got to find the similarity ratio. That's what I have to find. So that similarity ratio is just going to be 3 over 2, right? That's what those simplify to. So in other words, the ratio from this one to this one is 3 over 2. And then I just use that similarity ratio to find the perimeter. So I'm saying, okay, the ratio of this one to this one is 3 over 2. So it's 3 over 2. And then I'm trying to find the perimeter of this one, right? So it's like, well, 3 over 2 equals 381 over some perimeter equals 381 over some perimeter. Then it becomes 3p equals, what was that, 762. And so P equals, let's see, I could just do this out, I guess, but it's 254. My math is wrong, my bad. I do know that it was going to be less than 381, right? Because this is the smaller of the two. But once I divide it by 3, you would have a calculator. So you definitely would make sure that would be right. And so in other words, the perimeter of this one is just 254, and that would be meters, right? Perimeter, just normal units there. Okay. And now to do the area, right? Because that's what the next one asked me for the area. Well, remember the area doesn't have the same scale factor. The area has the same scale factor squared. So what I would do is I'd take this ratio, 3 over 2, and I would square it to find the ratio between of the area. So this is the ratio of this is the scale factor and the ratio of the perimeters. This 3/2 squared would be well, we can simplify that just to 3 squared, 9 over 2 squared, 4, so 9/4. So the ratio of their areas is 9/4. So I just usually write it next to them. It's like, hey, that's 3/2 is the perimeters, 9/4 is their areas. I just square the similarity ratio. So in other words, it would be, so if I was trying to find the area, it would just be, a mystery area here. So it would be 9/4, right? Boom, like this over that equals this area over x, right? Some mystery area. So equals 1944. Oops, that's horribly drawn. It's 1944 over the missing area that I'm trying to find. Delaney asked if the variable was always in the denominator. No. It just like again, if this is in reverse, I could have just as easily said like 2/3 equals p over 381. As long as I'm writing, as long as I'm sort of matching them up properly. Like if I was trying to find the perimeters, I could have just as easily had these flipped. It doesn't have to. The way that it worked out in this case was that I was going left to right, so it would end up being on the bottom just because of how I sort of looked at it and said it. So it doesn't have to be. In this case, it was though. So 9, A equals 4 times 1944. You're gonna have to solve that one out. I actually don't know what that is. I don't even want to. I mean, I guess I could if you really wanted me to simplify it. I don't want to. You figure it out. I do know that it's gonna be less than 1944 though. It would have to be. Well, actually, I could divide that by 9, so that would just be 200, 144. 416. So 216 times 4, 864. Again, that's some fuzzy math that I'm working on there, but 864 square meters. Again, I'm doing that in my head. I hope that's right, but you would have a calculator to bloop, 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 like that. You don't have to make those noises, though. Please don't. Okay. So that's pretty good. Again, I like that you asked that question. That was a good one to look at. If you, let me see. Yeah, let me see. I'm looking at that. Yeah. So yeah. Just as you're tying, no similarity ratio. Again, there's not a whole ton of stuff, and that's why again it's the whole chapter we did in 5 sections we did in like a week because there's not a ton of stuff, and they relate to each other. Like, this is hey, we're cross multiplying and we're solving those proportions. That's what the whole first section was about. We're writing ratios. Similarity ratio is just a ratio between two sides that are corresponding. Um, so it's kind of like we look at the similarity statement to find what things would be. If you're doing 10 and 11 and you did 18 and 19 and you could do these questions 24 through 26, like those are good sample problems for this particular section. Also, the shadow problems, I think there's at least one of those probably in here, right? Similar triangles, blueprint. Okay. Yeah. Yeah, scale model, right? That's a good one. Make sure you can do the scale model ones. Make sure you can do the, mm, I guess we did that as an example, but the shadow problem is definitely one. Again, I don't know how many times I can say that one over and over again, but look at that one. Um, let's see. So yeah, I without any other specific questions, I can go over general things, but I think we probably hit most of it. There's not a ton of stuff. If you do have any specific questions, feel free to ask them, but also if you forget them or want to ask them later, make sure you just send me an email or something. I got a bunch of emails to get back to you from today that I didn't look at while I was in the jury duty. Actually, I was in the jury pool. I never actually made it on a jury, so I'm not sure if I can say. Yeah, do those. I don't have a ton of those like extra ones of those, but we did I think 5 of them or at least 4 of them. if we skipped a day. I think one period or two periods skipped one of the days. But the main, I mean, I actually kind of went through how to do those, already. This is like an unlimited amount of ones you can pick. You can also like, hang on a sec. Let me just show you what I mean. Graphing. Like if you look up just like something like Desmos, I think it's just like desmos.com. I mean, really, you can put in equations here. So I could, if I wanted to, like if you look down here, there's this keyboard that you can do like square root and stuff. So if I did like where's the negative? If I did like no, not that. Okay, there's x. I don't know, I guess I can use the keys, but I know this thing is in my way. If I just did like radical, like x minus, first of all, you could see what happened. Y equals radical x, there's your graph, right? I mean, is basically, yeah, what I said, right? But then, and you can just test, like be like, okay, well then what would y equals, I don't know, like 2 radical x be? Okay, well it just is the same thing except it goes up quicker. Okay, well then what would, what if I made that negative? What is that? Can I not do negative? Negative, right? What would that look like? Okay, it's not letting me do that. Oops. Yeah, there it is. So if it was negative, right, what would it look? Oh, it goes the opposite way. What if it was, I don't know, plus 3, and then on the outside minus 4? Like, what would that look? Oh, there it is right there, right? So you can just say it shifted over 3 to the left 3 and down 4. It was flipped of that one. Its y-intercept, it had no x-intercept when you solved it. It wouldn't have made sense. It would have been negative. But its y-intercept would have been, I don't know, about 6.7 or something. So we would know it would have went in this direction through here. That's kind of the idea. Is you can just, I mean, you can make an unlimited problem. Just change the numbers and see what happens, and then do the 5 things that there were, right? I think there were 5. It was graphing it, but you're graphing it by doing a bunch of these other things. But graph by finding the x-intercept, finding the y-intercept, finding the shift, right? Right, finding the shift of that origin. Uh, the origin's not shifting, but finding the shifting of like the vertex of the V or the beginning point of our radical. They probably call that something, but I forget. And then this is just online. I pulled this up in 2 seconds. All I'm saying is that you can basically just plug in things to figure out what it would look like. Again, I think there's an absolute value, right? So I could do, if I did y equals absolute value of, like, just if I did x, right? And there it is, right? And you can turn them on and off just so I can just see the ones I'm looking for. All right, what happens if I do -6? Oh, it shifts down 6. What happens if I put a -3 on the inside? Oh, it goes to the right 3. Again, you can get a pretty good idea, right? If I threw a negative out front, oh, it goes the opposite way, right? I mean, just saying you can sort of see what's happening, where these x and y intercepts are, and stuff like that. So just if you, again, if you listen at all, if you followed along with the do nows and you look at them and you understand what's happening, they're not going to be any more difficult than the ones that we did, but they're going to be on that level of those things. So x-intercept, y-intercept, domain and range we talked about as well, right? We did talk about the domain and range. So graphing, y-intercept, x-intercept, domain, range. Okay. What do you think? You don't have to worry about that one. Okay. That's a pretty interesting looking graph though. I mean, if you think about it, that was pretty cool. I don't know. I just picked a random one. Anyway, um, all right. So I'm feeling good about this, guys. Judging just looking at some of the titles of these emails, I'm assuming no one's going to get the extra credit for everyone showing up in class tomorrow to take it because people are asking for extra time. One day I was looking the other way, and so I wasn't there for like 30 seconds mentally, so I needed an extra day to study. Even though, yeah, there's a lot. I don't know what they say actually. I'm just giving you a hard time. But the point is that if everyone's there, everyone gets a point. It is a test. There's no dropping this one, so make sure you're studying for it. Start off strong. I don't want to you have to use any of my grading ink, so they're all perfectly right. You know, that would be great. Uh, all right. I think that's it. Oh wait, okay. So if there's any other questions, that's good. Otherwise, there's one intro that again, I feel like that's all that has to be, right? It's again, there's this guy, right? He doesn't, do anything crazy. He plays Mario online. But my point is that the intro video is pretty straightforward, guys. It's just, wait, let me see. Okay, are you ready? Wait, you can't see it. Well, if there's any other questions, let me do those first. I'll give you 30 seconds. Okay, so we're good. All right. All right. So this dude, right? Okay. So look. So look. Easy. Boom, boom, boom. Nice little song. Bloop, bloop, bloop. Boom. Back to it. Easy. You know? What do you think about that? I think it's pretty good. Okay. Anyway. I think I'm out. See you guys. Oh, did I even show? Oh, I didn't even show the audio. I think that's all right. There's a little do 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 bloop 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 bloop, and then it's gone. See, that was it. Easy peasy. Anyway, I'll see you guys tomorrow. If there's any questions, let me know via the email. Make sure you smash that like button. There were like 13 of you in there, and I got 3 likes, so that's not a. I don't know how that works. But I don't think it matters at all. But you can do it if you want. That'd be cool. Makes me feel good inside. I don't know. Anyway, um, I will see you. I'll catch you guys in the next one. Yeah, I will. So yeah, where's my button for ending? I don't know. Ending. There you go.